All right, let's talk about spectrum sharing. It's this invisible, absolutely genius system that keeps our entire wireless world from just stopping. It's really the secret sauce behind everything, from your Wi-Fi router to the 5G in your phone. So let's just jump right in with the big problem this whole thing is trying to solve.
So think about it. Right now, there are billions of wireless devices online, and more are connecting every single second. How in the world do they all communicate at once without it just becoming a giant chaotic mess in the air? Well, the answer is actually pretty amazing, as you're about to see.
So, here's what we're going to cover. First, we'll look at the problem, that wireless traffic jam. Then, we'll get into what spectrum sharing actually is, the rules and the real tech that make it happen, see where it pops up in your daily life, and then, of course, take a peek at what's coming next.
Okay, first things first, let's really wrap our heads around the scale of this problem. Why are our airwaves getting so crowded? Well, it boils down to a classic conflict between what we have and what we want.
I mean, it's pretty much a perfect storm, right? You've got way more devices, a very limited amount of space for them to talk, and everybody wants to do data-hungry stuff like stream 4K video or game online. It's kind of like having millions of new cars hitting the road every day, but the number of highways never changes, and everyone wants to be in the fast lane.
So, what do? We can't just magically create more airwaves. The only answer is to get a whole lot smarter about how we use the ones we've got. And that brings us to the hero of our story, spectrum sharing.
Before we get any deeper, let's make sure we're all on the same page with this one word, spectrum. All we're talking about is the whole range of invisible radio waves that carry every single wireless signal. The most important part to remember, it is a finite, natural resource. Just like oil or fresh water, we can't make any more of it. What we have is what we have.
You know, the easiest way to picture this whole thing is to think of spectrum as a massive, invisible highway system just for data. Every bit of information from your phone or laptop is like a tiny car trying to get somewhere. So if spectrum is the highway, then spectrum sharing is like the super advanced traffic control system. It's really just a collection of really clever techniques that let tons of different cars or data streams use the exact same lanes without crashing into each other. It's all about efficiency.
And the goals here are really simple, but they're incredibly powerful. First, you want to use this limited resource way more efficiently. Make sure no lane on the highway is sitting empty if someone could be using it. And second, cut down on those digital traffic jams so everything keeps moving nice and fast.
Now, just like a real highway system, not all lanes are created equal. There are different rules of the road depending on which frequency you're on. So let's break down the three main ways we access this spectrum. This table really lays it all out. On the left, you've got licensed spectrum. Think of this as a private toll road. A company like AT&T pays big money for exclusive rights to use it for their cell network. In the middle, there's unlicensed spectrum. This is more like a public city street. It's open for everyone. That's why your Wi-Fi, your neighbor's Wi-Fi, and your Bluetooth headphones can all work at the same time. And then on the right, we've got the cool hybrid, shared spectrum. This is like a smart HOV lane, where a system decides who gets to use it and when. A perfect example is something called CBRS, where the Navy's radar gets first priority. Some users can buy priority access, and then whatever is left over is open for general use, all managed automatically.
Okay, so we know there are different kinds of roads, but how does this traffic management system actually work? Let's get into the real engineering, the core techniques that make all this sharing possible.
Okay, the first method is called time division. The best analogy is a single-lane tunnel where cars have to take turns going through. It's the exact same idea here. Different devices use the same frequency, but they do it one after another. This switching happens so ridiculously fast, we're talking millions of times a second, that to you, it just feels like a constant, smooth connection.
Next up, frequency division. So instead of everyone taking turns in one big lane, this approach splits the highway into a bunch of smaller, narrower lanes. Each user gets their own little dedicated channel so they can all transmit at the exact same time without getting in each other's way. This is a super fundamental technique. It's been used in everything from your car radio to early cell phones.
Then there's spatial sharing. This one is just plain clever. Think about how you can listen to a radio station on, say, 101.5 FM in one city, and then you can drive a few hundred miles, and a completely different station is using that exact same 101.5 FM frequency. That's spatial sharing in a nutshell, just reusing the same frequencies in different places that are far enough apart so they don't interfere.
And finally, we get to the most advanced method, dynamic spectrum access. This is like a futuristic, AI-powered traffic control system for the data highways. It's constantly watching for traffic, and it can open and close lanes on the fly.
basically giving spectrum to whoever needs it the most in that exact moment. It's incredibly smart.
Now, I know this can all sound a little abstract, but I promise, you are using these sharing techniques every single day. Let's look at how they show up in the tech you use all the time.
Seriously, this stuff is everywhere. Your home Wi-Fi? That's classic unlicensed sharing. It's that public street where your phone, your laptop, and your smart TV are all politely taking turns. Your cell service? That's a licensed private toll road that your carrier owns and manages to make sure your call doesn't drop. And that CBRS smart HOV lane we talked about? It's already being used to build private 5G networks for places like factories and to bring high-speed internet to rural areas.
And this is absolutely critical for what's coming next. The whole promise of 5G, insane speeds, connecting everything you can imagine, is completely built on these advanced sharing techniques, especially that dynamic spectrum access. Let's be clear, without smart sharing, 5G just wouldn't work. Period.
So it's pretty obvious spectrum sharing is essential. But like any big technology, it's not a magic bullet. It comes with its own set of challenges to overcome, but also some absolutely massive benefits.
On the one hand, trying to manage interference between potentially thousands of users is a massive engineering puzzle. You have to coordinate all these different systems, and you have to make sure it's all secure. But the payoff is just huge. We get way better use out of our limited spectrum, we can support billions more devices, and we unlock the door for the next wave of tech, like the whole Internet of Things.
So, if you're going to remember 3 things from all this, make it these. Number 1, spectrum is a finite and incredibly valuable resource. Number 2, sharing is the only way to use it efficiently and avoid total digital gridlock. And number 3, it is the absolute foundation for our modern wireless life, from the Wi-Fi in your coffee shop to the 5G in your pocket. To put it as simply as I can, spectrum sharing is the complex, invisible dance that allows our hyper-connected world to not only work, but to grow and get better all the time.
And that kind of leaves us with one final big question. We're getting really good at sharing our airwaves. As we move into a future where literally everything is connected, our cars, our homes, entire cities, what's the next critical, limited resource that we're all going to have to learn how to share? Definitely something to think about. Thanks so much for tuning in.